Good evening, Dr. Garrett, and welcome to my humble office. Thank you for the opportunity to make up this work and to make my presentation to you about the performance comparison of R22 and R410A. This is the first phase of my senior project, Noel 277, by Matthew Peach Matthews. It's 11:20 p.m. and so I'm still within the 24 hours. Because the technology is not presently with me to show a dual image of my presentation with PowerPoint and the video, I'll just advance the slides manually and also forward you a copy of the PowerPoint so you can see that. The introduction of the problem is there is currently now a phase out of R22 regulated and mandated by the EPA. Most current residential systems are R22, and if they are over 10 years old, most likely they are R22. R22 is now obsolete, and any new equipment made today has to be void of any R22 refrigerant. Customers and contractors don't know enough about the two refrigerants to formulate an informed decision on which route to take and what purchase to make and why they need to even make the purchase. The purpose of this research is to learn about the performance differences between R410A and R22. In that way I can give my customers an intelligent response to why they even need to purchase the equipment and what they can expect performance-wise with the new equipment versus the R22 equipment. The organizational content of this study will be done with around-the-clock contracting. Around-the-clock contracting will utilize this information and use it in the field with real-world interactions and daily business with customers to operate a daily standard of information sharing and with clients. The setting of the problem is, as I said before, most air conditioners in the United States are over 10 years old. Most air conditioners, upwards of 90% of residential air conditioning, contains R22. The Montreal Protocol in 1986 called for a phase out of all CFCs, and by 2020 it's mandated through the EPA that all R22 production be completely banned. That means any new refrigerant, any new refrigerant equipment, anything with R22 or even the substance R22 will be banned, and no more production will be ongoing, just as the case is with R12. Even currently there's a ban on any new equipment containing R22. And customers can expect to spend several $1,000s for upgrades and replacements that most people don't understand why they need it. And so there's a lot of frustration there, and there's a lot of bewilderment on the customers and the public at large why they have to spend these thousands of dollars because their equipment is not able to be fixed because it's obsolete. A little of the history is that the Montreal Protocol was established. It's an international community of countries established in 1987 in Montreal, Canada. They formulated a plan to phase out chlorofluorocarbons, and they began a program to reduce and eliminate R12, which was the primary refrigerant of the day. It's still, by all specifications and standards, performs wonderfully, except that it is a chlorofluorocarbon and contains a chlorine molecule and being a chlorofluorocarbon versus a HCFC like R22, the chlorofluorocarbon misses the one molecule, makes it lighter, so it's more subject to be blown up by winds into the ozone, and that chlorine molecule, according to the EPA, is what destroys the ozone layer and contributes to what they say climate change. Nevertheless, they've banned it, and R22 has been the refrigerant of choice in the residential sector for over 4 decades now. So you can see that over 40 years' time, people have come to depend on R22 for the comfort in their home. The scope of the project will focus only on R22 and R410A. It will examine the performance differences between the two refrigerants in identical circumstances and pressures and temperatures, expansion devices, and equipment. It will focus on the thermal exchange properties of the two refrigerants, given that all variables are the same. The information in this project will be gathered from previous research companies, institutions, engineering firms, and various authorities. Around-the-clock contracting will not perform any experiments in and of themselves. We will, however, pull from the experience and knowledge from professionals in the field that have analyzed this data and researched it and verified that all the numbers are correct. The significance of this research will impact my clients directly, and even people in the classroom, because everyone sitting in the classroom and at S&U, I assume, to live in an air-conditioned structure. Most structures made today are not made to be occupied without air conditioning because of the insulation and sealing properties and such. And so this is a significant project for anyone interested in planning for their future, their retirement, the current standards of life, any kind of upgrades, any kind of maintenance, purchases of a home, anything like that. This research affects them, because people should know why they have to spend these thousands of dollars and exactly what they're getting for their money. Besides, it's just a new refrigerant. The significance of this project will allow people that I come in contact with through my business and around-the-clock contracting, will allow me to interact with them and inform them about the various performance differences, so they'll know exactly what they're getting for their money. Some of the definition of terms are R22 is the chemical, the number assigned to the chemical, which is an HCFC blend, which is a hydrochlorofluorocarbon blend. R410A is the other numerical assignment to the refrigerant that is a hydrofluorocarbon. Various institutions make these refrigerants, but they're both called by the same name. Whether they're made by DuPont or another company, they're still recognized by that number, and they have to be so we can accurately service equipment. EPA, of course, is the Environmental Protection Agency, and the Montreal Protocol is the group of international companies that have come together in agreement to reduce CFCs and HCFCs and the impact they cause to the environment. Some of the resources I looked at were just two sources for this small presentation that was EPA.gov and the New York Times. There's a lot of information, and I thank you, Dr. Garrett, for allowing me to present this presentation to you. And I hope everything goes right, and I hope you enjoy the presentation, and I look forward to working with you in the future. Thank you.